Okay, so we multiply the first equation by the 4. We got 20x minus 8y equals -4. Now we're going to take the 2 and multiply the second equation with it. So 2 times x will give me 2x. 2 times 4y will give me positive 8y. And 2 times 35 will be 70. So I've multiplied everything on the top by 4 and everything on the bottom by 2. And now I'm going to use addition. I'm going to add these two equations down. So 20x plus 2x will give me 22x. Negative 8y plus 8y will cancel out. That's the whole point. We're eliminating one of the variables. In this case, we decided to eliminate the y. And then we have -4 plus 70, which gives me positive 66. And now I can solve this equation for x by dividing both sides by 22. And that gives me x equals 3. Once I have that the x is equal to 3, I can then take either one of my original equations, and wherever I see an x, I'm going to put a 3. So if I take the first equation, I'm going to do 5. Here's my 3. My x is 3, so I'm replacing the x by 3. So this is 5 times 3 minus 2y equals -1. It does not matter which equation you use because you'll get the same answer. 5 times 3 gives me 15 minus 2y equals -1. I want to have the y's alone, so I'm going to get rid of this 15. I'm going to subtract 15 from both sides. That gets rid of my 15, so I'm left with -2y equals, well, -1 and -15 is -16. And I divide both sides by -2. And that gives me that y equals 8. And I did see people said, and you could leave your answer like this: x equals 3, y equals 8. Though very often it's written as an ordered pair. Remember, in the ordered pair, the first number has to be the x, and the second number has to be the y. So you could write 3, 8, which I did notice some people did write that answer. Is there any question about how to do this method? Anybody have any questions? Okay. So if there's no question about this, I'd like to go and show you. Can we go over that? Yes. Rachel, would you want me to go through from the very beginning, or is there someplace in the middle? Should I start it from the beginning?
So what I wanted to know is the equation is going to come like that, but I need to know where you get the 4 and the 2 from.
I'm not understanding you. You're not clear.
I'm sorry. I just want to know where the 4 and the 2 come from.
How do you feel today, Ryder?
I still didn't understand what you said.
She wants to know, like, you see the beginning where the parentheses are. She wants to know, how did you get the 4 to multiply and the 2 to multiply?
Thank you. Thank you. All right. You know what? I'll start it from the beginning. Here's what I started out with. I started out with these two equations: 5x minus 2y equals -1, and x plus 4y equals 35. And even though somebody else suggested that I get rid of the x's, I decided today I wanted to get rid of the y's. Now, this is totally it's totally in your control as to what to get rid of. But it's a decision that you have to make right at the beginning. Do I want to eliminate the X? Do I want to eliminate the Y? Now, I decided that I wanted to eliminate the X. I'm sorry, I decided I wanted to eliminate the Y. So if I wanted to eliminate the Y, I had to look at the coefficients of the Y, the numbers in front of the Y. And I multiply each equation by the opposite coefficient. So the first equation, I'm going to multiply by the 4. The second equation, I'm going to multiply by the 2. And notice when I look, my first step is just to look at the numbers. Do not include the sign. You're first just looking at the numbers. So that's where I got the 4 and the 2. Is that okay, Rachel? Okay. Now this question is, do I have to use a minus with either one of them? Sometimes you just leave both of them positive, and sometimes you leave one of them positive, but the other one you have to make negative. And you do that based on the original signs of these coefficients. When the two coefficients are opposite signs, that's what you're trying to accomplish. You want them to be opposite signs, so then you just use the positive numbers. But if both of them have the same sign, they're either both positive or both negative, you're going to have to use one of these numbers to be negative so that you'll change the sign of one of them so that one will be positive and one will be negative. The whole point is that eventually, after you've done that multiplication, that the coefficients of that variable that you decided you wanted to get rid of should have the same number in front of them, but one should be positive and one should be negative. Because then when you add those two equations together, you will eliminate that variable. Do you want me to go further on this, or does that solve your problem? Does anybody else have any questions about this? Should I give you another one to try before I go into a different method? Actually, this one came right off of the final Math 136 final. So let's try one more, okay? And while you're working on this, then I'll take attendance. Okay, let's see if I can find another example. Actually, I'm taking it off the practice sheet. Let's try this one. First equation is 2x minus 3y equals 13. And the second equation is 5x minus 4y equals 22. Okay, and I'd like you to solve this system of equations. Lou? Lou? So, Mary, do you have a phone? Here, I don't need it. Well, there was some phone off.
Okay.
Okay.
So I got rid of I'm gonna use the y's. So on top, I'm gonna multiply by 4.
So what did you multiply the top equation by?
4.
-4, -4, because it's minus
Wait,
4y. You got to do -4 parentheses.
let's just talk about the numbers and then we'll talk about whether we should use a negative or not, okay?
Okay.
What did you multiply the bottom equation
By 3.
by? 3, okay.
Oh my God.
Now, once we decided on the numbers, now we're gonna decide whether we're gonna use any negatives or not. Did you decide to use a negative?
I didn't.
You did not.
No.
What,
That's where my mistake was.
yeah, let's think about it.
Oh, because there was 2 negatives, so we have to switch one of them to a positive.
What?
Is it because there were 2 negatives, you have to switch one of them to a positive?
No. Okay, so Jennifer, when you have two equations and it says minus 3y minus whatever, you're supposed to put you're supposed to multiply the first equation by -4. Then you get -4 times +2, you get that's -8x. And then negative times a negative, that's a positive. And then yeah, so forth. You get it?
Okay, I see where I got it wrong.
I'll try to make it even simpler. Let me make it simpler. Look at the signs. Are they the same or are they different?
They're the same.
When they're the same, you have to use a minus. But if one would have been positive and one have been negative, then you leave them then you don't.
Okay. Okay.
It's as simple as that.
Does it matter which one do we use?
No, it does not. Which
Okay.
one would you prefer using the most?
I'm just gonna use -4.
Okay. So so first we look at the number. Let's just remind ourselves. We look at the number, multiply by. Now, sometimes they're easier numbers to use, but this method that I'm telling you will always work.
Okay.
If you look on Delta Math on this, sometimes they'll give you different numbers to use, but you can always use this method. Multiply each equation by the opposite one, by the opposite coefficient, and then if they're both the same sign, make sure you use a negative with one of them. If they're different signs, don't use any negative, okay? What are you getting on your first equation then?
So then it's -4 times 2 will give you -8.
Okay, so we have -8x, okay.
-4 times 3 gives you -12.
Wait, look at your signs. Be very careful with the signs. This is where you're gonna.
Negative and a negative.
Is what? What happens when you multiply a negative? By?
+12.
It's +12, right? 12y. And next?
And then -4 times 13 gives you -52.
Correct. And
that's where I made my mistake. I get it now.
Okay, now let's go to the next equation.
It's going to be 3 times 5x is going to give you 15x minus 12y.
Right, because a positive times a negative is going to be
equals 66.
And now you can, even before you do any work, you can tell you're on the right direction. How do you know?
Because of the 12s.
Get rid of the y's. And the way you'll know that you're going to get rid of the y's is that they have the same number in front of them, but one is positive, one is negative. So that when you add it, they'll just drop out. Okay. So what do you get now?
You have to combine like terms.
Right.
So a -8 plus 15 gives you 7x equals negative
Okay, let's cancel that.
52 plus 66 is 14. A positive 14, then you divide by 7. So x will come out to 2.
Are you finished now?
No, you have to find the other one.
Okay, how are we going to find the other one?
You have to plug it in. You have to plug in 2 for the x's. So I guess we could use the top one.
Okay,
So it'll be 2 times 2 minus 3y equals 13.
correct.
So 2 times 2 is 4 minus 3y equals 13. We have to get the variable by itself, so it's -4 minus -4 on the 13. It'll be -3y minus 9. It will equal 9, and then divide by 3. -3
My -3.
equals negative y equals -3.
Correct. And now you're finished. Your answer
So
is
the answer is 2 and -3.
perfect.
Thank you. I see where I messed up.
Okay. That just, so you have to make a decision at the beginning as to what you want to get rid of, and then just multiply each equation by the other coefficient.
Okay.
That was perfect. Does anybody have any questions?
No, can you not erase the board?
Okay, I'll leave it on for a minute. Yeah. Just tell me when I'm okay to erase the board.
You can erase it.
Okay, great. All right, I'm gonna put on another problem on the board. And I'm gonna show you how there is another method that we could sometimes use. Now, if you prefer always using this elimination method, it's fine. The only time you would have to use the other method, the graphing method, is if it specifically says draw the graph or solve graphically. Then you'd have to graph it. So we already have two methods. We have the graphing method, which we said was cumbersome. It took a long time. And number two, not only was it cumbersome, it wasn't always so accurate because our graphing is not always so perfect. So this elimination method that we've been using has been quicker and for sure accurate. So I want to show you one other method that is also what we call an algebraic method. It doesn't involve graphing. It's just an alternate way of doing, instead of doing elimination. So let's say I had these two equations. Supposing my first equation is x plus y equals 11. And suppose my second equation is y equals 2x minus 1. Now, again, it's a system of equations because we have two equations with two variables. You have an x and a y, though it could be an a and a b. It doesn't have to be x and y. Usually those are the most common one. But if you notice, well, the first equation is in what we call standard form. We have the x, we have the y, we have the equal sign, we have the number. The second equation is not in standard form. It doesn't have x, y equal number. It actually is in what we call the y equals mx plus b form. It's really set up great if we wanted to do graph it, but we don't want to do it by graphing. If I wanted to use the elimination method, I would have to rearrange the terms in the second equation so that I would have the x first, the y second, the equal sign, and the number. And actually, I'm going to, after I do this method, I'm going to go back and I'm going to show you how we could have done that, and we could have used our elimination method. But when we have the system of equations set up so that one of the variable equations starts either y equals or x equals, it's actually a great setup for a method that's called substitution. Substitution means use one thing in place of another. If you look at it, here's my equation 1, here's my equation 2. In equation 2, saying that y equals 2x minus 1 is actually telling you that y has two names. Y has the name y, but also y has the name 2x minus 1. When you say two things are equal, it means they're identical, and one could be used in place of the other. So I can either use the name y, or I can use the name, of course I have to use the whole thing, 2x minus 1. So here's what I'm going to do. I'm going to go to my first equation, and in my first equation, wherever I see a y, I'm going to replace the y by its other name, which is 2x minus 1. X plus, now here's my y, which I'm now calling 2x minus 1. Now you can put it in parentheses, or you don't have to put it in parentheses, and that equals 11. It's called substitution because I've substituted for the y it's what it's equal to, which is the 2x minus 1. Now, why is that a good idea? Because now in this new equation that I just wrote, I don't have any y's. I only have x's, and therefore I can solve the equation for x. I combine the like terms. X plus 2x is 3x minus 1 equals 11. And that'll give me, when I bring the 1 to the other side, 3x equals 12. And divide both sides by 3 will give me x equal to 12 divided by 3, which is 4. Once I have what the x is, and I can go, and I can use either one, I'm going to use the second equation. I'm going to replace the x by 4. So then I'll get y equals 2 times 4 minus 1. So that's 8 minus 1, which gives me 7. So my solution to my system of equations is 4, 7. And you could check it. 4 plus 7 is 11, and 2 times 4 minus 1 is 7. Both equations work. This is what's called the substitution method. So when do I use the substitution method, and when do I use the elimination method? And when do I use the graphing method? Well, the graphing method I only use if I'm told specifically I must do it by graphing. If you'll see it on a midterm, they'll show you pictures of graphs. You'll have to figure it out from the graph. But if it just says solve, even if it says solve by elimination or solve by substitution, really the decision is up to you. I'll tell you how I make that decision. Usually, when I see the equations lined up in standard format, I right away go to the elimination method. The only time I use the substitution method is if I see one of the equations, could be both, but one of the equations saying specifically y equals something or x equals something, so that it looks like it's ready to be replaced. Otherwise, I use the main method I use is the elimination method. I'm going to do one more with like this with you, and then I'm going to give you time to try one. But before I do this, I want to show you that if you didn't like this method, we could have actually done this using the elimination method. I think that for this particular example, the better method was substitution. But let me show you that we could have used elimination as well. The first thing would have been to take equation number 2 and bring the x to the other side so that it's set up in what we call standard form. So I would have to get rid of the x from the right side and bring it to the left side so that this equation became negative 2x plus y equals negative 1. Now, if I look at my two equations, they're both in standard form. And now I can decide to get rid of one of the variables. Let's say I wanted to get rid of the x. Then I'd have to multiply this equation. Well, the number in front of the x here is 1. And this equation, the number in front of here is 2. Remember, I only look at the numbers first, not the sign. And since this is negative and this is positive, I don't have to use any negative. So that my equation, my top equation, since I'm multiplying it by 1, stays negative 2x plus y equals negative 1. And my second equation, I'm multiplying everything by 2, becomes 2x plus 2y equals 22. And when I add these two equations down, negative 2x and 2x, we're eliminating it. Y plus 2y gives me 3y. Negative 1 plus 22 is 21. And when I divide by 3, this gives me that y equals 7, which is exactly what I got on using the substitution method. Once I have my 7, I can go to either one of the equations. Let's say we take the first equation. I'll go over here. And I'll do x plus, well, my y I now know is 7 equals 11. And that gives me x equals 4. And I have the exact same answers that I got by the other method. So if you really love the addition method, the elimination method, it would have worked in this case as well. Any questions about this? Okay, so I'm going to give you another example to try. The first equation is y equals 4x plus 12. And the second equation is 2x plus 3y equals negative 6. Okay, I'm going to give you a few minutes to work that out. And you could do it by any starting the, okay. Which method did you use, Azia?
First, I tried the substitution method, and after, because I was not too sure, so after I used the other one.
Okay, let's see what you do with the substitution method. What did you do?
Okay, in the second equation, I replace x equals 4x plus 12.
Okay. In other words, you took out this y and you put.
Yeah, and I put 4x plus 12.
Okay, so
Plus 12.
x and the 3.
3,
The y. Now we're going to have to put a parentheses because
yes,
there's a number in front of it. Replace
4x plus 12.
and that gives me. That was
Is 12x.
oh, well, okay, let's it's equal to -6.
Oh yeah,
So this I left alone, right? And then what did you get?
12x plus 12. Oh, let me plus 36.
Right. Don't forget, this y is being replaced by the 4x plus 12. So we have to multiply, since it's 3y, I have to multiply everything by 3. So this becomes a 36 as well.
Because
That's why I
negative
put it
6.
in parentheses, because this thing is a unit. I'm replacing it by the unit 4x plus 12. And now we use distributive property. Okay, now go.
Now we have 14x
Right.
equals -6 minus 36.
Okay, so she's bringing this 36 to the other side. She has -30. And how much does that give?
42.
Right. Positive or
Negative 40, negative 42.
two? Okay. So what did you get for x in the end?
3 minus 3.
X equals -3.
Oh, negative.
Notice, I think for this one, again, using the substitution method made a lot of sense because the first one told us
Get out of this instant.
is equal to 4x plus 12. So wherever I had the y in my second equation, I could substitute 4x plus 12. Don't forget with this parentheses. If it's just, sometimes you don't need to put the parentheses there because there's no number, no coefficient. There is parentheses. Is this finished, Zia?
No, we're gonna look for the y.
Right.
Y equals, we already have x equals -3, so we're gonna replace
I hear you. Okay. Your son is helping you?
I don't know what to say.
First equation, we're taking that -3 and we're replacing the x with it. So there's 4 times -3 is
-12 is 0. 0.
Okay, so your answer is -3, comma 0. Did you get that same answer when you used this?
Yes, yes.
Yes. So as you notice, it's good to have an alternate method. And as I said, the more common method to be used is the elimination method. But when you have explicitly one of the variables in terms of the other, either x equals or y equals, then substitution is very often a good alternative. Does anybody have any questions before I go on to the next section? We now know how to solve systems of equations. It turns out that a lot of word problems, a lot of real life situation type problems can be solved with using a system of equations. So and actually on our practice sheet that I had sent you out, there happened to be quite a few word problems. And that's what I'd like to concentrate on for the rest of this period. How can we set up a system of equations to solve a verbal problem? And then how do we solve it? So if you have practice sheet 3 in front of you, then you can read along with me. If not, I will put the important bits of information on the board. So this is question number 7 on that practice sheet. One number, using the symbol for number, is 5 more than the other. Their sum is 10. And the question is to find the numbers. In other words, one kind of word problem that we can have is just a regular number problem. Information about numbers, and we want to write an equation or a system of equations that will work to solve this situation. So far, really, the only type of word problems we've done have been the word problems that had to do with the perimeter of a rectangle. And that we didn't need a system of equations, we just used one equation. Now we're going on to other types of examples. And the question is, how will I know that I need a system of equations? What is a system of equations? A system of equations is 2 variables, an x and a y, or whatever other letters you want to call, and 2 equations. Once you have 2 unknowns, 2 variables, you must get 2 equations. And I use that whenever I'm looking for 2 different items. And if I look at this, look at the question. One number is 5 more than the other. We're talking about 2 numbers. So since I'm talking about 2 numbers, let's call one x and one y. And we're going to have 2 variables. So we're going to need 2 equations. We're going to need a system of equations. Whenever I want to solve a verbal question, the first thing I really want to do is decide what I should call my variables, make what's called a legend. Write down what your variables stand for. Because if you know what your variables stand for, then it's going to be easier to write the equation. So I know I have 2 numbers that I'm looking for, so we'll call them x and y. And now let's call x the first number, because they didn't distinguish between the 2 numbers. And let's call y the second number. And now that we know what we're using as our variables, let's see if we can write the equations. Now, instead of reading the whole thing, when I have a word problem, I read the whole thing through. Decide what I'm looking for. Look what they're asking for. They asked you find the numbers. I didn't write that down. Because if you know what you're looking for, if you know what your equation is your question is asking for, you'll know what your variables should be. After you've decided what your variables are going to be, in this case, we're going to call them X and Y, then slowly go back and reread the problem in parts. One number is 5 more than the other. Let's start right there. That's sentence number 1. That gives us one bit of information. One number, let's call it X, is, how do we write is in mathematics? We make an equal sign. 5 more than the other. What are we doing when we have 5 more? What operation are we doing? Anybody? Addition, right, absolutely. We are adding. More means adding. I'm going to take my second number, which is the Y, and add 5 to it. 5 more means, now I could have done 5 plus Y, but I really like to put the variable first and then the adding. If it would have been 5 less, that would have meant to subtract 5. You would have done 5 less than the second number would have been Y minus 5. When you're adding, the order you do it in doesn't make a difference. When you're subtracting, you have to be careful. Well, now we have our first equation. Let's go to the next line. Their sum is 10. That's my second sentence. It's giving me information to write a second equation. How do we write that the sum of the numbers is 10? Sum means, what do you do? What does the word sum mean? What operation is that? Does that mean Y is 10 when it says the sum? Okay, somebody said sum, right? Sum means to add. So let's put the 4 important words that we might have. When you talk about the sum, you're talking about addition. The sum is the result of adding 2 numbers. Sum means the result of adding. I'm trying to think. Difference. What operation am I talking about when I say the difference of 2 numbers is 10? What is the operation then? Anybody?
Subtraction.
Subtraction. So either we say minus or we say difference, and that means subtraction. Okay? Product, the product of 2 numbers.
Multiplication.
That's multiplication. And remember, you could either use a dot or you could use a times sign. And quotient is the answer you get when you do what?
Divide.
Divide. So those are the special terms that you really have to know, because very often they're going to use the product of 2 numbers is. They're going to tell you the product. You're going to have to know that what they want you to do is multiply. Here they're saying the sum of the 2 numbers is 10. Now, what are my 2 numbers? My numbers are the X and the Y. the sum means I have to add them. So my second equation becomes x plus y equals 10. And now I have a system of equations because I have equation number 1, x equals y plus 5, and equation number 2, x plus y equals 10. I have my two equations. I'm going to give you a few minutes to try and solve this system of equations. Does anybody want to guide me through solving this system of equations? Anybody willing to help me with solving the x equal y plus 5 and the x plus y equals 10? Anybody willing to help me? Nobody's volunteering? I guess I'm gonna have to do it myself. Do you hear me? Can you hear me?
Yes, we can.
Okay.
Well, I can.
Yes.
Okay. If one of you can, then it means then it's my, okay. All right, so I actually look at this system of equations from this first problem. And I say, oh, my first equation says x equals y plus 5. And my second equation says x plus y equals 10. So my first equation explicitly tells me what x is in terms of y. I think this is a good example to use substitution. In my second equation where I see my x, I'm going to put y plus 5. So it's going to be the y plus 5. I could put this in parentheses, but I don't necessarily have to because there's no number in front of it. I'm not going to be multiplying it. So I'm just replacing x with y plus 5. So I have y plus 5 plus y equals 10. And now I can add the two y's together. Y plus y gives me 2y plus 5 equals 10. Subtract the 5. And that'll give me, going over here, 2y equals .
Professor, can you lower your screen a little? Because I can't see the bottom of the board.
Okay, I'm getting 2y equals 5. And if I divide by 2, I get y equals 5 divided by 2. I'm going to use my decimals, 2.5. The first number I got was 2.5. Now, how am I going to find the second number? My x is the y, 2.5 plus the 5, which gives me 7.5. So it turned out that these numbers didn't come out to be whole numbers. They came out to be fractions or decimals. You could have written it 5 halves. You could have left it 5 halves, but it was easier just to take my calculator and do 5 divided by 2 and get my answer as 2.5. And my first number is 2.5. Actually, my first number is 7.5. And my second number was 2.5. And notice if you add 5 to 2.5, you do get 7.5. All right. I'm going to give you a few minutes to try. Can you read that problem? We'll try not to go too low on that one. Can you see the next problem? Okay, I'm going to give you a few minutes to write the equation and try and solve that. I'm going to erase this problem so I'll have the room on the board to work on. The big thing is getting the right system of equations. So let's read the question carefully. We have the sum of two numbers is 32. One number is 4 less than 5 times the number. Other, find the two numbers. So we know in our example, we want to find two things. We're looking for two numbers. So let's call our first number X, and let's call our second number Y. You wanted to call one L for larger and S for smaller. You could use any letters you want. I usually like X and Y, but you can use any letters. But we know that we have two numbers, one is X and one is Y. The first statement tells us the sum of the two numbers is 32. What equation do I get from the fact that the sum of the two numbers is 32? Anybody?
X plus Y equals 32.
Correct. Sum means add. We're adding the two numbers. X plus Y equals 32. So we have one equation, but we have two variables. So we need a second equation. It's a system of equations. So I go to the next statement. One number is 4 less than 5 times the other. So one number, let's call it X, is. Remember when we have is, it's always an equal sign. 4 less. What are we doing with the 4? If it says 4 less.
Is it a negative?
Right. It's going to be, and it's going to be a -4 at the end. We're going to, when I say 4 less than 20, I don't do 4 minus 20. I do 20 minus 4. 4 less than 20 means that the 4 is the thing that's being subtracted. English and math don't always coordinate exactly. 4 less means that we're going to be subtracting at the end 4. 4 less than 5 times the other. 5 times the other, well, the other was Y, so 5 times, how do you write 5 times Y? What does times tell us to do?
Multiplication.
Multiplication. It's 5, 1, yeah. So the second equation, one number is 4 less than 5 times the other, becomes X equals 5Y minus 4. The only thing you have to be really careful about is when it says less than, that you subtract it at the end. Don't put it at the beginning. Don't put the 4 first. It's the 4 that's being subtracted. It goes at the end. Now we can solve the system of equations. Again, it looks like I should use substitution because it's telling me that X equals 5Y minus 4. I can replace in my first equation, I can replace the X by 5Y minus 4. So I'll get 5Y minus 4, in place of this X, plus the Y from before. That's going to equal 32. When I combine the like terms, I get 5Y and Y gives me 6Y. Minus 4 equals 32. And now I just add 4 to both sides to get the Y alone. That gives me 6Y equals 36. And divide by 6. And that gives me that my y is 36 divided by 6, which is 6. And to find out what the x is, I can go to this equation and I can do x equals 5 times 6 minus 4, which is 30 minus 4, or 26. So my first number, my x came out to be 26, and my y came out to be 6. Notice when I add them, 26 with 6 does give me 32, so it does check. So this is how we solve word problems that involve numbers. Now, I want to do one other type of example. The homework that I'm giving you, and there is going to be homework, the next homework number 7 on Delta Math. Aside from the quiz, there is a homework on the systems of equations, but it doesn't include any of the word problems. That's going to be next time. It's just the working out, just actually solving. But I want to get started on a type of problem that often gets asked as a system of equations. It's a problem that involves how much things cost. You have 2 types of items. It could be sodas and bread. And you know how many items you're buying, and you're knowing how much each item, the price of each item, and you know how much you're spending on it, and you want to know what's the price of each items. Sometimes it's items that you buy in a grocery. Sometimes it's clothing. I have 2 types of shirts. I have red shirts and blue shirts, and I know how many I have, and I know how much I'm spending, and I want to know how much each shirt costs. It could be questions about tickets to a movie or something of that nature. All those type of questions basically get set up by systems of equations in a similar way. So I'm going to read you a question, and I'm going to work it out. And on Thursday, we will continue with this topic.
Professor.
Yes.
So the homework is going to be on the system and equation of substitution and elimination.
Right.
Okay.
Okay. Okay, don't worry about the word problems yet. That'll be the next step. Okay, so here's the question. Tickets to a local movie. I'm not writing that they're to a movie. So we have tickets to a local movie were sold for $5 for adult tickets and $3 for children's tickets. So again, we have 2 types of things. They happen to be tickets to a movie. One type of ticket is called an adult ticket. It costs $5 each. For the children, the tickets cost $3 each. 100 tickets were sold. And the 100 tickets sold for $450. A total of $450 was made from selling these 100 tickets. Remember, there's a combination of tickets. Some of them are adult tickets, some of them are children's tickets. We want to know how many tickets were adult tickets and how many tickets were children's tickets. Okay, now we have to set up our legend. We have to decide what our variables are. Now, always to find out what your variables are, read what you're looking for. how many adult tickets were sold, how many children tickets were sold. There are two things that we're looking for. Do you want me to, can I use X and Y?
Yeah.
Okay. So here's my way. Let X be the number of adult tickets sold. Notice I don't just write let X be adult because I don't know what that means. Adult what? What? So that's why I'm reading what I'm looking for. I'm looking for how many adult tickets were sold. What is the number of adult tickets sold? So that's why I write let X equal the number of adult tickets. It's much more specific than just saying let X be adult. Obviously, then the Y is going to be the number of children tickets sold. So step one, I've written my legend. I decided what my variables stand for. Now I go back and I read my information. One bit of information is it tells me the price of each adult ticket and the price of each ticket. We have that written down. Now let's look at the major information at the bottom. 100 tickets were sold. Can I write an equation that tells me that 100 tickets were sold? Anybody have any idea what equation would I get from saying a total of 100 tickets were sold?
Wouldn't it be equal?
Okay, but what equal?
X.
X plus Y.
X plus Y, good. The total number of tickets means everything together. What are we doing with it? They didn't use the word sum, but we're adding them. The total number of tickets, X plus Y, is 100. Here's our first equation. Add the X and the Y, the number of adult tickets to the number of children's tickets. That'll be 100. That's your first equation. So adding the two together, that gives you the first equation. But we didn't use the fact that it was $450 that we made. How do we figure out that? So notice we didn't make any use of the fact that the price of the tickets were different. When I say X plus Y, it has nothing to do with how much each ticket was cost. The total number of tickets was 100. It didn't matter what each ticket cost. But the $450, that depended on the price of the ticket. So then I have to include the 5 for the adult and the 3 for the children. In other words, my second equation becomes 5x. X is how many adult tickets were sold. Each one was $5. So the amount I'm making on the adult tickets is 5x. The amount we're making on the children's tickets is 3y. Notice I'm including the price of the tickets when I use the money. That all adds up to $450. So my first equation that just talks about how many tickets or how many sodas or how many shirts were sold, which doesn't include anything about the price. We just add the X and the Y and we get that number. But once we start talking about how much money we're making, then we have to include the price of each item as well. Now that we have our system of equations, we have both equations, and notice they are now set up as standard equations. They're in the perfect setup for elimination. So let's decide, do we want to get rid of the x's or do we want to get rid of the y's?
The y's.
Okay, let's get rid of the y's. If we're getting rid of the y's, I will multiply the top equation by the 3. And the bottom equation, well, what's in front of this y? Understood to be a 1.
1.
Divide that by a 1. And before I finish, I have to decide, do I have to use a negative or not? Well, both of these have the same sign. Remember, when they both have the same sign, I have to use a negative. Should I use a negative with this one or with this one? Does it make a difference? Should I use it with the 3 or with the 1?
With the 3.
Okay. Actually, it doesn't make a difference. You shouldn't use it with both of them, but you can use with either one. I can either put the negative, I need to use one negative. I can use it with the 3 or I can use it with the 1. The reason, again, why I have to use that negative is because both of these numbers are positive. Okay, so going on, taking the first equation and multiplying it with negative 3 will give me negative 3x minus 3y equals negative 3 times 100, which is negative 300. Multiplying the second equation by 1 just leaves everything the same. 5x plus 3y equals 450. And when I add these two equations down, negative 3x plus 5x, that gives me 2x. The negative 3y and the positive 3y, that cancels out. We said we wanted to get rid of the y's. That's exactly what we are doing by getting them to have opposite signs, but the same number. And negative 300 plus 450 gives me a positive 150. And if I divide by 2, that gives me x equals 75. So what is that telling me? X stands for,
You sold 75 adult tickets.
so there were 75 adult tickets sold. How many children tickets were sold?
We have to plug in the 75 to the x.
Okay, so let's do it in this first equation. 75 plus y equals 100. I always go to the original equation rather than one, because it's always simpler. Subtract the 75 and we get y equals 25, which tells me in this particular problem, 75 adult tickets were sold and 25 children's tickets were sold. And this type of problem, I would say they have it on almost every midterm and final. This idea of two types of items being sold and the price of each item, they're always set up the same way. Okay, I'm going to, does anybody have any questions they want to ask? Okay. So let me remind you that you have until Thursday morning to do the quiz number 2.
When are you gonna grade that like next week, right? We'll know our grade.
Doesn't it tell you the grade right away on,
No.
you know what? I'm going, it doesn't give you the, I'm going to set it up so that you can see your grade right away. So on the first quiz, you had the same thing? You didn't see your grade right away?
On the first quiz, we saw our grade.
Yeah, on the first quiz, we saw it right away.
You know what? I'm gonna go back. Those of you who already took the quiz, I'm going to go back and reset it up so that it'll be like the first quiz. In other words, And if you're not happy with your mark,
We have to retake it because if we have to retake it, it'll be great. Because on the last question, right when I was gonna put in the answer, it kicked me out.
oh, you probably ran out of time.
I did.
Would everybody like me to reset it so they can start from scratch? Is there anybody who wouldn't be happy with that? Okay, you know what? So here's what I'm gonna do. I'm gonna reset it so it's gonna be more like the last quiz. Now, if on this quiz, I really did not, you took the test and that was it. On the last one, you had two chances to do each question. Did you like the fact that you had a second chance?
Yes.
Okay, so I'm going to go, I'm just going to reset the whole thing. I'm going to also reset everybody's mark then. Is there anybody who doesn't want me to reset their mark? It means that you're going to have to do the question again, the test quiz again. So I will extend it. Instead of giving it until Thursday, I will extend that quiz until Friday. I'm going to change the date. There is going to be homework for Thursday, but the quiz is going to be now due Friday, and I'm going to set it up so it's like the other one, so that you'll see your answers right away. And you'll get a second chance at doing a question if you got it wrong. Okay? Everybody okay with that?
Yeah.
Okay.
Yes.
If you're not happy with it, you have to, if you didn't do it yet, now you'll do it. No, there not too many people had done it yet. It was fine. If most people had done it, I wouldn't go back. It wouldn't be fair. So if you, the other thing I did want to say something. I'm going to check how I will be sending out, after everybody has completed quiz number 2, I will send you out an email telling you you're standing on as of now. Now, basically, the only thing I've given you is work on Delta Math. Later in the week, probably Thursday or Friday, I will tell you when there's going to be a test on Blackboard. We're getting closer and closer to the midterm. We have actually one chapter to do before the midterm. And I want you to be practiced in the way the tests on Blackboard are given. Now, in those tests, you're not going to have any, you're going to have to, it's just going to be multiple choice, and that's going to be the answer. But it'll be a multiple choice question. I probably will give you something like between 15 and 20 questions. The midterm itself is usually 20 questions, but I'm going to give you a setup so that you'll be used to doing tests the way they're going to be for the midterm and the final. And that's going to be our next test, which will include everything that we will have learned so far. It'll be the first 3 chapters, but I'm not telling you exactly when it's going to be. I first need you to finish quiz number 2. Now, if anybody has any questions.
So after quiz number 2, you're gonna tell us, you're gonna email us to know where we are.
Right.
Okay.
Though you'll probably be able to tell on your own because you'll know. Specifically, I'm going to there are some people who are really getting behind on the homework. At this point, you will have to have done 7 homeworks and 2 quizzes by Friday. And over the weekend, I will tell you where I think you stand at this point. Obviously, it doesn't tell you what you're going to get on your final grade in the term, but it gives you an idea of where you stand at this point. And if anybody is not happy with a mark that they got, or they want to do something additional or retake something, all you have to do is let me know and I'll work with you. I want to see you get good marks. And if it means that you retake a test, or you redo homeworks that you weren't happy with, I'm glad to reset things for you because I want to see you working, and that's what I find is the most important. So that's why I want you to be aware of what's going on. Melissa, you taking off over now? Is Melissa here?
I see her there.
Because usually she takes over. She's here. Melissa?